Okay, announcement. So now you got all your marks for lab test 1. Check the ePost link and also the feedback command. So for written parts, I just posted this morning. Have a look. If you want to talk about it, just come to my office hour. For lab test 2, which is going to happen next Monday, I posted the guide over the weekend on Friday. And then this time, notice that the programming part will be 40% and the written part will be 60%. So I encourage you to put more focus on the written part. Of course, the programming part is also important, but also do the written part as well. Okay, I'm going to post the solution for the practice test maybe on Wednesday or Thursday. So do take advantage of that between now and Wednesday and Thursday to take it for your own. Especially for the programming part, I would suggest try to do it almost like a test to simulate the test environments for yourself. Give yourself no more than 15 minutes to do it, no more than that. Okay, that would be my advice. Okay, now let's go back to a very quick recap of what we did last time about aggregation. As I said before, the diagram you saw on the slides, you are not really expected to draw it, but you're supposed to actually read it. Okay, let's read it together. So every time when you see a box, so for example, course and faculty, so these are simply just class names. So that means we have a class called course, and also we have a class called faculty. And then notice that at one of the ends, we have an empty diamond over here, like over here. Empty diamond tells you sharing is possible, it is allowed. So that's aggregation. We'll see something slightly different for the diamond shape a little bit later when we talk about composition, where sharing is forbidden. And then this is how you should read it. And then you should always see what's the corresponding Java code to implement this diagram. For example, over here, when you see over here, okay, when you see you have a course class over here, and also you have a faculty class. Okay, so this is how you should read the diagram. Every course has a single, so this tells you how many containees there are for each container. Each course has a single faculty object called instructor. Okay, that's how you read it. How do you reflect this in the Java class? It's very trivial, very straightforward. So that means you have a course class over here, and the course class, you have an attribute called instructor. The instructor over here corresponds to the instructor over here. And then the one over here corresponds to just a single reference type. Okay? If that's star, which is in the other case, that will be an array type or array list type. Let's see the other case. The other case, we still have the diamond shape over here for aggregation. So we have two classes, student and course. And now let's read it in a consistent way. Every student object has the star means multiple, 0 or more. 0 simply means the collection is simply empty. More means the collection can be as big as possible. Every student has 0 or more courses as their courses, course object as their courses. And how do we reflect this on the Java implementation? In the student class over here, we have an attribute called courses. And courses over here correspond to the courses over here, right? And then, how do we reflect that there are multiple containees for each container? Well, we simply say, for example, array type, or it can be an array list of course. Okay, and then you also got the faculty and course classes defined separately. Okay, it's a very quick recap. Any questions about this? And also last time we actually visualized two big examples about how aliasing will actually work for sharing at the runtime. So today we're going to do one more example about aggregation, but I'll focus more on how you can use a dot notation for aggregation. And then we'll move on to composition. And then we'll try to visualize everything again, right? And hopefully we can finish composition today, and we can move on to inheritance, which is the biggest topic for this course. Okay, we'll get there. Say it again? You mean the diagram? From left to right, yes. The way you read it is from left to right. For example, course has one single faculty as their instructor. Okay, good. Okay, good. Let's see the dot notation. So now, this is not really something new, but maybe giving you a little bit more different perspective to understand the dot notation. Basically, we call Java the object-oriented programming language, and dot notation is really one of the features that really features object orientation. Let's see how. Let's just use one example over here. Okay. let's say we have the following 3 classes. Okay, it's complicated enough. And also we got basically 3 classes. We got student, we got course, and we got faculty. Let's read it together. Okay, we are saying that every, you can see the cursor here. Every student has 0 or more courses as their courses. I just call it CS. Symmetrically, every faculty has 0 or more courses as their teaching. I just call it TE, right? So now you can imagine how to implement it accordingly in the Java classes. Okay, you can see that exactly. Let's see some and then let me just mention a few points, and then we'll see some code. So here, this is how we reflect that diagram into the Java classes, right? We got 3 classes over here. For example, you can see for students, we simply got an array list or array, depending on what you want to do. And then the star over here is reflected as an array list. Okay, and then we got CS here. Okay, and the rest. So we got 3 classes. And then I'll show you a little bit more code, and then we'll try to do practice together. And we really want to get insight into dot notation. Okay. So now let's first of all talk about aggregation links. Just from the diagram, we can do some traversal or navigation. So the fact that students has a link to course, and course has a link to faculty, for example, that means maybe somehow we are able to go from student to course and course to faculty. And how do we go from one class to another? The answer is you use the dot notation. So the way you traverse through the aggregation link, each single link corresponds to a single dot in your Java code. Okay, that's the principle, but we'll see, exercise together. And now here's a very, very important concept to bear in mind. Whenever you talk about a dot notation, the class in which you are writing this dot notation is really important, which means a context class. Okay, we'll see different notion in just a moment. Okay, for example, let's say we are now talking about in the context of student class. Okay, and now we can say if you in the student class, if you say CS, you're talking about the attribute CS. There's going to be an array list of courses, right? That's a very simple one. How do I refer to a particular course for these students? What should I say? Rather than all the courses as an array list, I want to go to just one particular course. Let's say I want to go to the course at index 1, the second one. You can say cs.get index 1, right? That's how you do the array list. It's starting from index 0. So I say the second one, so it would be index 1. Good? Okay, that's a very simple example. And we'll do something more complicated. Now, I want to show you some code very quickly to begin with, and then we'll try to extend the code by using dot notation. Okay? So now let's see how we are going to implement a student class. Apparently, we need to have a way to say how can a student add a new course, and how can a faculty add a new teaching courses, right? Things like that. It's very standard. And now since we're using the array list, so we can simply call the add method, which we did in lab number 3. And if that happens to be an array, you can just use the number of courses, right? The pattern that we talked about for lab test 1. For example, for the student class, you can simply have a method called getID. Okay? Let's go to the example right away over here. Okay? Now, let me ask you this. It's a very simple one. If I'm now in the context of the student class, what should I write in order to return the ID for this particular students? Return. If you say return ID, how do you know it actually makes sense? If you say return ID, how do you know you can just use ID? It's an attribute, exactly. So the reason that I'll show you some comparison right away. Just for this particular one, since I'm now in the context of, again, context is really important. I'm now in the context of the student class, so I can refer to any attribute as I wish. So that's why I can simply say return just this.id, right? Okay, let me do a comparison for you. Okay. So now first of all, let's see some diagram over here. Okay, let's see them together. Now let's say I have let's say I use yellow to highlight over here. Let's say I have a student object over here, so there's a student objects. And the student object has the courses attributes, and at the moment, let's say we got 2 courses object being referred to. Course number 1 and course number 2, okay? And course number 1, the blue link, is referring to, let's say, the course with title 2030. And course number 2 at index 1 is referring to the course objects with title 2001. Okay, just an example. And we also got 2 faculty objects at the other end. So let's say the first faculty is Jeff, and second one is Jackie over here. And let's say Jeff is currently teaching 2001. That's why you see a pink link, right, from the first element of the teaching array list. And also for me, that will be the teaching the first course, let's say 2030. Okay, a very simple example. Now I want you to compare several things. Okay, I want you to see exactly what's going to happen over here. Let's say I want to refer to this particular name, Jeff. Let me make it a little bit simpler for you. If I want to refer to, let's say, over here, this particular faculty objects, okay? How can I do that? Okay? There are actually basically 2 missing links. I'm just going to do that now. Remember, every course has a attribute called prof, right? Let's just do that very quickly. Let's say over here, you can see that for 2030, I'll just let the prof link point to, that's the wrong one. I'll let it point to over here. Okay, hopefully you can see that. It's pointing to the Jackie faculty objects over here, right? And then you can see the 2001, the prof is pointing to this faculty objects over here. Let's see the symmetry over here. I'll just show you one. If you have a look at this, for this particular faculty object here, this particular faculty objects, Jeff is teaching 2001. Symmetrically, 2001 should also have their professor being Jeff. That's symmetric. Also similarly for 2030. Okay, so far so good? Okay, so now let's say this. How many ways are there for me to refer to this particular faculty objects? How many ways are there? How many ways are there? How many? Just give me a number. Let me just put one more information to you. Let's say currently this is faculty F1 and this is faculty F2. Okay? Now the question is, I'll put it aside, how many links are there to refer to this particular green objects? How many? Okay? Just give me a number. How many? Are you sure just 1? Are you sure just 2? Okay, let's see how about the shortest one? What's the shortest one referring to this green objects here? F1, thank you. I agree. F1 is really just this link. F1. Can you give me a slightly longer one? And what about, I forgot to add more information here, beg your pardon. What about I say this is C1 and this guy here is C2? Okay, how about just from the course perspective, what should I say in order to refer to green objects? C2.prof, agree? Okay, let's do that as well. So that would be C2.prof. Okay, let me just, so C2 is pointing to this object over here. The prof is going to refer to the same object here. Do we have any more? That one's going to be long, but try. Start from what? S, which is students, dot, be careful. The CS, dot, the get, right? That's an array list, don't forget. Get, and 1, are you sure? Good. Are you sure? Good, 1, yes, I'm sure. 1, yes. And then, after that, the prof. All right, that's good. So let's just verify that. So basically, starting from S over here, S is referring to here, the CS is referring to this array list, and then the get1 is going to refer to this particular course object over here, and then when you say the prof, is going to follow basically like this link over here. So 3 in total. Okay, one more thing. Okay, one more thing. from this small example, I'm going to extrapolate to some general cases for you. Now let's see this. You can see over here, prof over here, and the prof over here. They are basically referring to the same attribute called prof for the course class. Agree? However, the context objects is a little bit different, right? Okay? If you see that, if we simply say C2 over here, this is simply of type course. However, you can see that, of course, overall, when you say s.cs.get1, that's also of type course. Just that the way you get to this particular course is a little bit more detour. You got to start from S and then go all the way from CS and then go to this course over here, right? Okay, that's good. So now here comes the important thing. Since there are three possible ways for me to refer to this particular faculty objects, how many ways are there for me to refer to this particular string value? Also three, right? The same. Right? I can see whatever the path is, dot name. Okay, good. So now let's make things a little bit more general for us. Okay. So now let's see. Let's say in the student class, in the course class, and also in the faculty class, in three different contexts, I'm going to refer to the same information. Because the context is different, so the way we write a code it will be different. Okay, let's see. The easiest way would be, what about I just say here? Let's start from here. Let's say in the faculty class, I want to have a method where I want to get the name of the faculty. Okay, in that case, what should I say? Return this.name, right? Because we got an attribute called name. So that will be return this.name. And, right? So far so good. You can think about this over here is like F1, the faculty. It's like that. Because F1 is of type faculty. So this, whatever this is going to be replaced by F1. Okay, let's get a little bit more complicated. What about we go to, in the context of, get instructor name over here? What would that be? Let's say I'm already in the context of this particular course object for 2001. How can I get my particular instructor's name? I should first go to the faculty class, right? I should navigate first. So how do I do that? Let me start from this dot prof, and this will allow me to go to this particular faculty object and then dot name. Well, I can say get name or name. Okay, so also good. Okay, let's get to the fun part. What about this one here? I still start from this, and this basically is the context for where I'm writing this code, which is students, right? And then what should be the rest? This dot cs dot get, and whatever I is, well, I'm just making it more general, right? Okay, I, and then I would say dot prof, right? So if I'm here, I'm going to get a prof dot name. Okay, hopefully you can see from this comparison over here, even though we are trying to get the same information, we are trying to get the instructor's name, but depending on where you're writing this particular dot notation, the context will be different. So the form will be different. If you get the context wrong, or you write the dot notation wrongly, it's not going to compile. Okay? Let's do more exercise. How about that? Okay. Any question about this? We good? Very good. Okay. All right. Okay. What about get course title? Now we are in the context of student class. How do I get a course title? What should I return? Return something like that, right? You can. Oh, one more thing to mention. Okay. Notice that the way we define the method over here. One thing to note. You can see for this one here, it doesn't take any arguments, right? And for this one here, also it doesn't take any arguments. But for this one over here, it does take an argument I. So there's a reason for that. The reason is, in the case of the course class over here, because the containee has only a single one, that's only a faculty, so you don't need to know which one to go to. On the other hand, for the case of the students, it has multiple containees for the courses. That's why you need an I over here to tell you which one to go to, first of all. Okay, that's the idea. Okay, okay, let's go back here, and then so now how do I get to a particular course for these students? Okay, I should just go to get cs.get what I and then dot title. Okay, okay, very good. Okay, this one we have seen already, right? Okay, that one's the most complicated one. If you can understand it, then we are fine. Okay. Okay. And the next one would be, if I want to get a title for the course, it's easy, just get a title. If you want to get the instructor's name, can I say just say return prof? No, the type wouldn't match, right? If you said return prof, it's going to return you a faculty object rather than string. That's why you're going to say return prof.name. Okay? And similarly, how about this? This one's interesting. Let's say, let me try to get it right. Basically, let's say given 2001, for example. Given the 2001 objects, I want to find out whoever the instructor is for 2001. And I want to get that particular instructor, go to their teaching duties and find out ith course for them, and then find out the instructor for that. Kind of a detour, right? Can you see how to implement that? Okay. Let's see this. Let's just see how it will look like in the implementation, and let's see how it can be reflected in the diagram. So what we're trying to do here, basically, first of all, for the course objects, first of all, get a prof. Go to that particular prof's teaching duties, and then go to this particular one and find out what the title is for that one. Okay? Let's try for this one here. Okay, just for this particular one, how do we do that? For example, over here, I'll write it down for you. So that's in the course, get course title of instructor. Okay, I would say it's now the course class over here, I'll put it here. So if I say C2 dot get course title of, I'll say ins for instructor. And then I want to go to, let's say, just 0. Okay, I'm calling that particular method. Okay, let's review again. How do we implement that? It's going to be this.prof, go to the instructor, and then go to their teaching duties, which is a list. Go to, let's say this, the one at 0 index, which is the first one, and then find out the title for that particular course. What's going to happen is, let me use a different color here. So now we have basically C2. That's the starting point, C2 over here. And then for C2, we want to get a prof, which is going to be basically this particular faculty objects. And then we want to go to their teaching duties at index 0. And this is the teaching duty they have. And go to index 0, which is going to refer back to this particular course and then get its title, which is 2001. Okay, so this one is going to return 2001 to you. Okay, this one is a little bit tricky. Okay, so maybe try to follow that maybe after the lecture. Okay, any question about this? The main lesson to learn from here is whenever you talk about aggregation, the main goal is to have so many links at the runtime so you can actually navigate between the objects or classes. Okay, that's really the essence for object-oriented programming. Okay. All right. If you have no question, let's go on. Okay, for this one, I'll leave as exercise for you. Okay, now we are done with the aggregation. Let's now go to one extreme, the other extreme, where no sharing and no aliasing should be allowed. Whenever we see any sharing or aliasing happening for the context of composition, there's certain violation we'd like to fix. So what I would do is I'll give you the same example, and then we talk about different concepts for the different variations for the same example. Just file and directory. Just make it easy. And for your lab number 3, I think one of you actually asked about how to implement a copy constructor. We'll talk about it just right over here. And also shallow copy versus deep copy. Okay, we'll talk about everything. Okay, now let's see the diagram here. You can see the diagram pretty much looks the same as aggregation. Can you see the difference? The diamond, right? You can see over here, the diamond here. simply saying that, well, let's read it together. Okay, let's read it. We're basically saying that every directory has 0 or more files as their containing files. Symmetrically, every file has exactly 1 directory as their parent directory. Okay, we just got 2, right? So now, very simple exercise for you, but you'll see in the slides anyway, is to think about how you can reflect this in the Java classes. Okay? Again, we wouldn't ask you to draw the diagram, but you should know how to read the diagram. Okay? A very simple multiple choice would be, is this composition or aggregation? Composition, right? Composition simply means there should be no sharing. The files should not be shared among directories. Okay? So let's see a different example. So what I will start with is, I'll give you one very neutral example. That's pretty much composition. There's certain imperfection over there. And then we'll go to the topics about copy constructor. That's what I will do. Let's just go over the code on the slide very quickly, just to see all the necessary lines, and then we'll see some tests all together on the iPad. Okay? So we have a class called file. Every file has an attribute called name. The name of the file can be f1, f2, f3, etc. And this is how we initialize a constructor, how we initialize a file objects. So given a string name over here, we're going to say this.name is assigned to name. I have a quick question for you. You can see we got this.name is assigned to name. So the type for name over here is string type. Is string a reference type or primitive type? It's a reference type, right? Be careful. Okay, it's a reference type. That means when we try to do this particular assignment here, are we copying the value for the string, or are we copying the address of the string? Address. Okay, bear that in mind. Okay, it's kind of important. Okay, and then what we have another. Okay, that's about file is easy as that. Okay, but we're going to modify this file in different variants. Now for the directory class, we got our patterns again, right? So we have, each directory has a name, for example, D1, D2, D3. And then we have an array of files, okay? And then we also got a counter here, number of files. Okay, I assume that you're very comfortable with this pattern here. And then we have the constructor. The constructor here, we simply do the similar thing. We simply say, given a name for the directory, for example, D1, I'm going to initialize the name to be the name. Again, this is copying the address, right, of the parameter over here. Again, call by value, right? Make sure you review that lecture. And also we say that files, which is an array, is going to be a new array of 100 slots. Initially, every slot is null. And finally, we have a add file mutator. Given the name of the file, f1, f2, f3, what we will do is we'll try to, first of all, so this is anonymous objects, as we talk about. So this one is going to create a new file objects with this particular name. And then we're going to assign this object to the right spot and increment the counter. Okay, that's a fair first version we're going to consider. I would say this version is pretty good. It pretty much can satisfy the composition. Okay, so let's have a look at some tests altogether. Okay, let's say this is the structure I would like to create. I got a directory D, under which I would like to create 3 files, F1, F2, F3. And I want to make sure no other directories can share the same set of 3 files. I want to make sure. Okay, let's see how we can do that. Okay, this is going to be the test. Let's just go to iPad and go over them. Okay, okay, it's basically the test over here. Let's try to visualize them. Okay, so this part we have gone through. This part we have gone through. Okay, let's focus this part here. So what we do is first line number 3. How is this line going to be executed? Let's try. So what I would do is for line number 3, over here, what I would do is D1 is now going to point to a directory objects, right? I'll just put D for directory. And then it's going to be of the name called D. And every directory has 1, 2, and 3 attributes, right? So now let's put all the 3 attributes over here. So we have the name of the directory, and now let's be more precise. The string at the runtime is actually an object. So that means name is really pointing to a string object over here, and it's simply just D. Okay, just the name, be more precise. And then we also have, what about NOF? Number of files is just going to be 0 to begin with, right? Like over here, right? I'm basically executing this part of the constructor. And also, the files over here is going to be an array of size 100, right? So what I will get is, it's pointing to an array of size 100. So it's going to be 0, 1, all the way to 99. Okay, that's what line number 3 will do for us. Questions? We're good, right? Good. Now let's see what line number 4 will do. And then 5 and 6 will just be similar. So I will do, what about blue? What about 4? So the current objects, the context object is D1. So we are talking about this particular objects. So when I say add file, we know that add file over here is going to just assign whatever new object we're going to create to the position NOF and then increment the counter. Let's do it. Okay. First of all, let's execute this particular line over here. And now we have f1.txt. That means we're considering f1.txt. And this is also f1.txt. Okay, that's what we have. So what we will get is something like this. So that means, let's create a file first. So we have a file object over here. File. Each file simply just got one single attribute called name. Okay? And then we got f1.txt. So that's simply pointing to, I'll just say f1.txt. So there's a string objects. Okay? And then we're going to, NOF is simply 0 at the moment. So make sure this at position 0 is pointing to that. And then we're going to increment this by 1. Okay, so the blue part is basically has this following effects. Okay, so far? Okay. So far, do you see any aliasing? Aliasing, more precisely, do we have any aliasing for this particular blue file objects? Do we? No, right? What would be the path to go to that particular blue objects? D1, starting with D1, dot, files, and then go to position 0, right? Okay, that's how we do. So there's no aliasing so far, okay? There's simply no way to refer to this particular blue object over here except this particular path, okay? No sharing. Okay, now let's do it quickly for the other two. Let's try the green one over here. I say d1.addFile f2.txt. Okay, it's going to be the same thing. Okay, I will do that quickly. I'll just create this new object over here, also file, and then it's going to be name will be f2.txt, f2.txt, and then I'm going to see the current value for NOF will be 1, so that means I should assign position 1 to be this particular object, after which I will increment the value by 1, that will become 2. Now, have we introduced any aliasing after this line? Also no, right? Because there's also only one way to refer to the green objects, which will be d1.files at position 0. Okay, that's also the same. No sharing. Okay, position 1. Thank you. Yes, thank you. Okay, let's do the last one. Okay, for the last one, so now we're gonna do this one here. It's gonna be f3.txt. Okay, let's do that quickly. So now again, we got a third object over here, and then we have name. It's going to be f3.txt. And then it's going to be at position 2. Position 2 is here, and then it's going to point to over here, and then increment the position by 1, so that'll be 3. Okay, so we've added the 3 files. So we are basically doing exactly what this requirement is asking us to do. Okay? So now, let's now just do some simple assertion. Okay? You can see over here, if I try to say assert true, will this equals be okay? How about this? Let me ask you a first question. Which equals will be called? It's going to be the equals from file, the equals from directory, or equals from somewhere else. String? Okay? Everybody is okay with that? Let's try. We're starting from D1. D1 is directory. And then when you say d1.files, it's going to be an array of file, right? And then you go to position 0, and that one is going to give you just a single file. And then when you say single file, does have a name attribute, which is type string. So that means over here, overall, this is going to give you a string type. Okay? So we've done quite a few examples like this. So make sure you're comfortable with long dot notation. So we do have a string. So string dot equals f1.txt. So would this be true or false? Given that, right? Of course, the best way is to look at the diagram, right? So now how do we do that? Let's use the color here. Let's say d1. d1 is referring to this object here. d1.files is referring to this array over here. Go to position 0. Position 0 is over here, which is referring to this particular file objects. And then .name, which is talk about this attribute here, which is referring to this particular string, f1.txt. f1.txt dot equals f1.txt should give you true, right? Okay, good. I would say you really want to get so familiar with such stuff without the help of any Eclipse runtime. Of course, it's nice for you to double check on the debugger, but if I give you something like this, maybe not in the lab test, maybe in the exam, so you should be able to trace it, right? Okay, anyway. Good, that's the first version. You can see there's no sharing. So that's a reasonable approximation for the composition, no sharing. Okay, so the conclusion from this example is no sharing. So this is composition. Okay, F1, F2, and F3, they are exclusively owned by this particular D1 objects. Okay, that's what you will see on the slides. There's no aliasing. But now, we're going to talk about a new addition to the directory class, which is called copy constructor. Okay, that's where the things will get a little bit trickier, a little bit. Okay, okay, there's the first version here, and then we are okay with this. Okay, everything has been set. Okay, so now let's go to the second variance. Okay, that's a diagram basically, just the same, just a little bit nicely drawn. Now we want to talk about copy constructor, which you see the dimension of that for lab number 4, not 3, lab 4. So what is really a copy constructor? First of all, it's just a constructor, okay? And then the copy constructor is so-called copy constructor because the parameter type is just the same as the current class. For example, if you look at, for example, for directory here, you can see this is the class called directory. And this particular method here is a constructor because it has the same name as the current class. And you can see we have only one single parameter, and that other has just the same type as the current class, right? That's why it's called a copy constructor. So what tells you a method is a copy constructor? First of all, it must be a constructor. And second, it takes a single parameter which has the same type as the current class. So these are the two criteria. Okay? But what is the copy constructor meant to do? Okay? The principle is very easy. You want to use this particular copy constructor to initialize all the attributes for the current class. For example, for the case of directory, how many attributes do we have? We have name, we have files, we have NOF. We got 3. Agree? We got 3 attributes. So that means we want to somehow use this copy constructor here to initialize all the 3 attributes. But by what values? The answer is you should really look at the argument object over here and try to figure that out. Okay? For example, since other is just of the same type as directory, so that means we can definitely say other.name. We can also say other.files. We can also say other.nof. We're going to copy all these 3 attributes into the current objects. That's why it's called a copy constructor. We simply copy the values from other objects in order to initialize all the attribute values for the current objects. Is it clear? Okay. We're going to see how we do it. Okay. And now, when we talk about copy constructor, so there are 2 ways for you to do the copy. One is called shallow copy. The other one is called deep copy. Right? So we should really understand how the shallow copy looks like and how the deep copy looks like, and know why only the deep copy is going to be 100% faithful for our composition purpose. Okay? That's kind of like a anticipation of what we're going to do. Okay, so now the question is, how do we implement this copy constructor? I'm going to give you, first of all, two versions to begin with. One will be shallow copy, the other one will be deep copy. Okay, let's see how we do that. And for both of them, basically we're going to initialize all the attributes for the current class. I'm going to use this. However, the way we do the copy will be a little bit different. Okay? And here is some guiding principles. We want to make sure we are basically consistent with, when I say copy and pasting a directory, which means you should just duplicate all the files. And also, you want to make sure there's no aliasing. Okay? You want to make sure. If there's any aliasing, that's not 100% composition. Okay? Let's see the first version. Okay? Shallow copy. So what do I really mean by shallow copy versus deep copy? Okay, let me just tell you over here. Okay, shallow copy. Let's see this. Let's say we talk about, let me remind you one more thing. I'll put it here. So we talk about copy constructor. Okay, that's what we talk about. And we have class, directory. And then over there, we have a constructor called directory. And then this is constructor. And then we have just another parameter has the same type as the current class called other. So this makes that a copy constructor. Okay, again, by this, we know that it's a constructor. And by this, which has a matching name of the current class, we know that it's a copy constructor. Okay, bear this in mind. So now we know that for every directory, we have 3 attributes. Let me just put them in the context. So we got 3 attributes. So the attributes we got name of the directory, and also we got files, and we got number of files. Let's keep that in mind. So now let's have a very quick sketch of what we're going to do. If you think about other, it's actually going to be, again, call by value. Other is at the runtime is going to point to some directory objects. And then let's draw that very quickly. Directory objects, and it's guaranteed every directory object has 3 attributes. It has a name, it has an array of files, and also it has a number of files. Okay, so far so good? Okay, and let me be a little bit more abstract over here. There should be a certain value over here for the name. There should be a certain value for the files, and there should be certain values for NOF. So far so good? Good. And now, there is a difference between shallow copy and deep copy. Here is the difference. Okay? Let me just put one more object in the context. Let's say I'm also talking about this. Okay? That's the current directory object I'm talking about. And then over here, name, files, and number of files, the same attributes. But now, what should be this value here? What should be this value here? And what should be this value here? So there are 2 ways to initialize these values, either shallow copy or deep copy. Shallow copy is very easy to see how to do it. Okay? Shallow copy simply means whatever value you have. Okay, let me just say one more thing. We call these attributes in the current class the first level. First level attributes. Okay, just first level. What can be the second level, by the way? The second level can be something like this. For example, at the runtime, we know that files is simply just an array over here with different elements over here. And as soon as I go to a particular element over here, this is called second level. Okay? So this one over here is, this attribute over here is second level. Okay? Just some naming convention here. First level versus non-first level. Okay? It can go as deep as the runtime might allow you to do. Okay? But for the shallow copy, we only do a first level copy. for the shallow copy. I'll write it down. For shallow copy, copy attribute values for first level, just at the first level, only these. And how do we copy them? Easy, just use a simple assignments like this. Okay, you can say something like, so what should be the value for this particular attribute here? So what I would say is over here, this dot name is simply assigned to other dot name. Shallow copy is actually quite cheap because for the reference type, are we copying the whole object structure or we're only copying the address? Only the address, right? That's why shallow copy is very cheap. But it does come with a price, as we'll see. Okay? And what about this one here? How do we do that? And over here, it's going to be basically this dot files is assigned to other dot files. I have a quick question for you. Let's link to our asymptotic analysis. For this particular assignment here, what would be the cost? Would it be a constant operation or quadratic or linear? Constant or linear for this one here. For this dot files is assigned to other dot files. Constant, right? Because there's no loop, I'm simply copying whatever address it is for other.fs into this.fs. So very cheap. That's for shallow copy. But as an anticipation for deep copy, you have to run a loop to copy element by element to make sure there's no sharing. Okay, so this one here as an aside is the big O of 1. Okay. Okay, finally, we can also do something like this. What about number of files? Well, number of files is of type integer. In that case, we simply copy the value for the integer, which is also cheap. Okay, we can simply say this dot NOF is assigned to NOF. So these are the 3 tasks to be completed for a shallow copy, just the first level. So first level in some way conceptually very easy. All the attributes for the current objects you're talking about, simply just copy their values from whatever other is as a parameter for the copy constructor. Just do a simple assignments. Okay, that's all we do. Oh, sorry, that's not what I meant to highlight. That should be assigned, assign, and assign. Any question about shallow copy? Can you imagine, I will definitely talk about this in more detail. This is only a sketch. Can you see any potential aliasing for these 3 assignments over here? Specifically, can we look at the second one? When I say this.files is assigned to other.files, am I creating any aliasing? I am, right? That means the 2 directories are pointing to the same array of files. So that means starting from the second level, we have aliasing. Anyway, so we'll see that. Okay? If there's aliasing, that means shallow copy is not 100% composition. Okay? Let's see. So now shallow copy. Okay, so let's try to trace the code and see how we can get to this issue here. Okay, so you already got the idea, but I'm just going to repeat again. For shallow copy, we have this constructor here, and also is a copy constructor because parameter type the same as the class name. So we're going to do 1, 2, and 3 assignments for the 3 attributes. So just do NOF, name, and files. Okay, and then we also have a method over here for adding the file, the same as before. Okay, let's trace the code again. Let's try to do this all together. First of all, let's do line number 1. We got directory D1 and will be D. So I would say D1 over here is pointing to a directory and then has 3 attributes. I would say name, number of files, and also the files. And the name will be simply D. Okay, it's pointing to a string objects, number of files will be 0, and then it's going to be, remember from the previous one. Oh, by the way, from the previous example, is this a copy constructor? That's the very first example we talk about for directory. Is that copy constructor? It is a constructor. It is not a copy constructor, simply because the argument you have over here is simply a string. It's not a directory, okay? Just as an aside. Okay, we know from before this is going to create an array of size 100, okay? I'm going to go back here, and then I'll put an array of size 100 quickly. 0, 1, 2, and then all the way to 99. That's what line number 1 will do, okay? And then let's do also quickly, this also we have done previously, right? Let me draw that very quickly. So I'm going to add 3 different files, F1, F2, F3, okay? So what I will do is I'm going to create 3 files over here, F1, F2, and F3. And then all of them will be file objects. Each file object has the attributes called name. And the first one is going to be F1 and F2 and F3. So first one, f1.txt, and the second one, f2.txt, and the third one, f3.txt, like that, okay? And then we're going to add them in. The first one, I'm going to add in because its number of files will be 0, so it's going to be pointing to here, increment it to 1. And the second call over here is going to look at the current position 1, so I'm going to add it to here, increment from 1 to 2. And the third one over here, I'm going to add to position 2 and increment it to 3. Okay, it's a very fast motion, but you know the idea. Okay, we have gone through this already. Let's now do something new. This line here. Let me use pink. What about this line here? Let's now study very carefully this line. This line here, I'm saying that D2 is also going to be a directory, objects, but now the way I create D2 is by using D1 as a source to copy all the attribute values from. So I'm calling a different version of constructor. I'm calling the copy constructor, all right? That means whatever I have initialized so far is going to be the source for me to create D2. Okay, let's see how it's going to happen. So now let's say, first of all, we have a D2 over here. I'll say D2 over here. And since it's going to be a new object, so I definitely have to create a box for the directory, D. And also it has the 3 attributes. I will simply do what about files over here, number of files, and also the name. And the name, okay, so far so good? So now the question is, what should I put over here? What should I put over here? And what should I put over here? What we will do is we're going to call this version of the copy constructor. That's what we're going to do. And we're going to do the assignments for all the 3 attributes. Let's see what's going to happen. Okay? Okay, let me just undo this. More precisely, you can see that D2 is now the context objects. Okay? D2, by the way, is the context objects for this case. Okay, let's try to trace the code. Let's say this is, let me just use a different color again. Let's say this is part 1, this is part 2, and this is part 3. Okay, we're calling that copy constructor. Now, what's part 1 going to do? Part 1 over here, because we know that the current object is D2, that means D2.nof is assigned to what's other. In this case, D1 is really the other, right? Call by value, remember, right? So now it's going to be D2.nof is assigned to other.nof. What's the consequence of that? Right? So I say D2.nof, which is over here, should be copied over the value for other. What's other? In this case, the other should be D1. Right? I should really put D1 here. Let me do it again. Right? Other should be D1. Okay? Should be D1.nof. D1.nof would be 3. Okay? That means I should put 3 over here. Oops, sorry. 3 here. Okay? That's easy. Good. What about when I say number 2? So this will be number 1. What about number 2? Name is assigned to other.name. Am I creating a new string objects? Not really, right? That's why I say you gotta be careful in this case. So now, basically I'm saying that, so number 2 over here boils down into something like this. I gotta say d2.name is assigned to d1.name. That means d2.name over here is going to point to this particular object, d1.name, right? So now let me just try to do, it's just pointing to the same string. Do we have aliasing? We do. What does that mean? If now I try to modify the name for d1, it's also going to modify the name for d2 at the same time, right? Aliasing. Okay, let's do the last step. For the last step, we're going to say files is assigned to other.files. So this is number 2. Okay. Number 3, basically we say d2.files is assigned to other.files. That's what we will do. And now, how do we draw the link? Any idea? Address, I agree. Yeah, I agree. Somehow we're copying whatever address it is for others.files. What's other.files? Other in this case is D1. Sorry, keep forgetting. It's D1. So D1.files is basically this address over here, which is pointing to this particular array. We're copying only that address, not the entire array. So that means what we will do is fs, let me just use a different color here, is going to point to the same array that is being pointing to. This is the most critical step you should understand. Let's do some very quick assertion altogether. Okay? After this, for example, you see that over here, when I say assert true, d1.files equals d2.files, should it pass or fail? Should pass? Let's see from the diagram. I agree it should pass, but let's see from the diagram. When I say d1.files, d1 is pointing to this object here. .files is pointing to this particular array. What about d2.files? d2.files basically is going to be d2 is pointing to this particular object. .files is also going to point to this particular array. So this is a phenomenon after the shallow copy, which means for the array, we don't actually copy everything in the array. We just copy the beginning of the array, the address. That's it. Okay? So that means we got aliasing. So there's a violation of composition because we do have aliasing. Okay? Then let's see how the aliasing is going to occur. For example, now let's say the following over here. If you look at this line here, when I say d2.files at position 0 change name to f11.txt. So what does that mean? First of all, how can I get to d2.files at position 0? Okay, d2 is over here, this object over here. .files is talking about this attribute here, which refers to this particular array. And then I want to go to position 0, which is referring to this particular slot, which refers to this particular file. Right? So now I want to change the name. Let's assume we do have a change name method for the file. And we want to change the name to f11. So that means we're going to change this over here to f11.txt. Here's kind of a critical thing, finally, to conclude this particular variance. What I just did, I tried to modify the very first file for directory D2. If composition was faithfully followed, this should not affect the first file for D1. It should not. However, would it? It would. Because now, if I try to run this particular assertion over here, if composition should be followed, that means it should remain to be f1.txt. It should. But turns out this assertion over here will be false. Why? If you look at that, when we say d1.files, so d1 is over here, this object here, .files is referring to this very same array over here that's just been modified because of aliasing. And then we go to position 0, which is this object that we just modified, just over here, this object here. And then what's the name for that? Well, it's simply f11.txt, the one we just modified. So it's not f1 anymore. So that's why this assertion should be false. That's also evidence why composition is not faithfully followed by this particular variance, by shallow copy. Okay, guys, are we good so far? Okay, kind of follow the story, right? So now, question is, how do we fix this? The reason that okay, let me just tell you again, recap very quickly. We talk about one way to implement the copy constructor, which is over here, by using shallow copy, which simply uses simple assignments over here for every attribute value. And the fact that we're using a simple assignments equal sign, that means we're only copying the address for reference type. That means unavoidably, you're going to have reference aliasing for sharing. Okay? And we simply see that from this particular assertion. Okay? That's how we did. Now, conceptually, can you think about any way to improve the copy constructor so that we can actually got no sharing whatsoever for the directory structure? Which means for D1 and D2, when I say I want to create D2 by calling the copy constructor using D1, I want to make sure I create some completely independent object structure, no sharing whatsoever. Which part do you think I should change? Which part? I got 1, 2, and 3, right? Remember? I got 1. Oh, sorry, that's another one. I got 1 here. I got 2 here. I got 3 here, right? Basically, whichever part that has aliasing, I should fix that. Which part got aliasing? 3, I agree. What about 2? 2 is all right, because you remember 2 over here, we also point to the same directory name object, right? So 2 parts we got to fix. Okay, so that means as far as this course is concerned, whenever we talk about deep copy, you just have to make sure you always create a new objects. Okay, and you will see the example when you do the practice test. Okay, now let's see how we can do deep copy. Okay, let's have a look at the code for deep copy. Okay, don't lose the big picture. First of all, we talk about composition with the first variation. And then we introduce the idea about copy constructor, and then we do the shallow copy. And then we realize for the shallow copy, it's going to introduce aliasing, which is not satisfactory for composition. That now we arrive the final version, which we'll use, deep copy. Let's have a look. Let me just go right to the end, to the conclusion. The idea is once we change the way we implement the copy constructor, which I'll show you line by line, but eventually, if we try to run the same assertion as before, we are going to get f1.txt, which means whatever change we made for D2 is not going to affect D1. So that means they're completely independent. Okay, that's kind of the conclusion we'd like to arrive, but we'll see how we do that. Okay, let's have a look. Again, this one actually nicely compare the two kinds of constructor we have. So this one here, again, question for you, which one is the copy constructor? First one or second one? How did you figure? Both are constructors. How do you know the second one is a copy constructor? Parameter, right? It has the same name as a directory. Okay, good. Okay, so we got two constructors over here. So now you can see that the deep copy over here is more complicated than before. Before we talk about, for operation number 1, simple assignments and also simple attribute access is a constant operation. For the second task for shallow copy, simple assignments and also simple attribute access, that's also constant operation. If you add up together, the shallow copy is simply a constant operation. But now what about the deep copy? Is it still constant operation? Well, if you look at the code structure, it's not really, right? Because we do have a loop. It should be at least linear, at least. Okay, so let's have a look. Basically, what we're going to do is, first of all, let's see, we also changed the constructor for file. Okay, so now the thing we changed was, whenever we're calling this new version of the file, by the way, it's not copy, it's also copy constructor, right? This is the copy constructor for the file class. And this guy over here is the copy constructor for directory. So every class can have its own copy constructor. Okay? Now, for the copy constructor for the file class, you can see that rather than saying this.name is assigned to other, right? Because now we do have another other.name. But you can see that what we do is new string other.name. So that means we are really trying to really make sure there's no alias even for the name strings. Okay? Okay, we will trace that in just a moment. Okay, so now let's have a look at the code very quickly, and then we'll see how we can do it. Okay? All right, so let's see how we can do it. This also shows you some nice syntax about using the constructor. Let's see, we talk about this particular copy constructor here, and then you can see for the first line, what does this line mean? Okay, this is maybe like a new syntax to you. Okay, you can feel free to use it for your lab or maybe your lab test. So when I say this over here, I'm calling some constructor in the same class with this particular argument value, right? And if you look at that, let me just explain that to you. So this over here basically is calling a constructor in the current class. Okay, that's what we're doing. But which one are we calling? Are we calling itself or are we calling the other one? How does Java tell? Well, you look at the type of the argument, right? So what's the type over here? Other.name, string. So that means it's calling this version over here. Okay? So basically, we're calling the normal constructor over here as a helper constructor, like a helper method, basically. Okay? Which means we're replacing these two lines by a single line over here. Okay? Feel free to use it. Okay? It's quite a good practice to do. Okay, we do that, and then we have a loop over here. Let's see what the loop is going to do. Okay? Basically, we're going over the list of files for this particular arguments over here called other. Okay, we just get I less than NOF, and then we're saying that create a new file, and then we're going to say create a new file, and then we're going to put it inside this particular directory. Okay, let's just trace the code all together, and then we'll see. Okay, so we got a file called source over here, and then we try to make a copy. Let me just compare these two lines for you. If you have a look at this line over here, the orange line and the blue line, try to look at these two lines. These are really the critical lines. For the orange line over here, we are basically just getting whatever other .files at position I is, right? And let source point to it, right? That's what we do. And then for the blue line over here, we are doing basically to say, given this particular source file that I just got, I'm going to call the copy constructor from the file class, and then make a copy of that, and make sure the file is actually a new object, and also the name of the file is also a new string object. That's what I would do. Okay? And then finally, I'll simply say, I'm going to call this dot add file, in which case I'll just do the normal line. So I just didn't include the details. Okay? That's kind of the big picture, but let's draw the diagram all together. Okay? Let's now draw together. Again, let's see, what about this line here? When I say directory D1 is assigned to new directory D, am I calling the copy constructor at the moment? Am I? No, right? Because you can see the argument type is simply string. So it's not really copy constructor, not just yet. And then let me do something quickly. This line and this line here, actually, let me just say this line first. And then next line will be something new. So what I would do is I would say D1 over here is pointing to a directory objects which has number of files. Let me put a name first. Has a name which points to the name D. Number of files should be 0, and also the files array should be of size 100 to begin with. 0, 1, 2, up to 99. Okay, that's what that line would do. The same as before, nothing special. But now what's going to be special over here is, let's try to see this. When I say d1, the add file, but this one is actually calling, let me just show you the one, so when you refer to the notes later. So just go back to the previous one. This is the version that it is calling the add file. So now we got two versions of the add file. Either we just give a string arguments over here, or give a file arguments. So two versions. Okay, so just make sure when you study the code, you will know where to refer to. Okay, so now let's see how this one is going to be executed. For this one, it's very easy. So f1.txt. So what we have is, let me just do it quickly. So now we got f, and also we got name over here. So that's f1.txt, and that should be pointed by the 0 index, and then we'll increment this to 1. And then we got a second file over here, that means a second call over here with f2.txt. And then f, the name will be f2.txt. And then currently it's 1, so now we're pointing to 1 over here, and increment that to 2. Okay, finally, we have this line here, f3.txt, right? And what we will do is we'll create a final file object over here, f, the name will be f3.txt. And then position 2 is pointing to it, and now we're going to increment that to 3 eventually, so 3. Okay, that's what these two lines will do. We have done that many times, so hopefully that's not an issue for you. So now the new bits. Okay, how do we analyze this line over here? That's basically the key. This one is going to call this copy constructor over here, which is a linear operation, which means what it will do is, it's going to, you can see over here, this is d1, which is the argument object. d1 is this object over here. We're going to go over the array one slot by another and copy everything over. That's what we will do. That's why it's a deep copy. It's much more work to be done than a shallow copy. Okay, let's do that very quickly. Okay. Okay, let's see. So how do we execute this particular call over here with d1? Okay, let's try. Okay, you know what? Let me try to make the things a little bit not so much just line by line. I'll try to maybe go over a little bit faster so you don't really lose the big picture. So now what we will do is, first of all, we're trying to execute, let me just try to use different color here. What about this green here? What's going to happen for this particular line? Okay, let's see that. Okay, what's going to happen is, by the way, other over here is going to be d1. Okay, other is going to be d1. d1.name will be basically just d. Okay, so what we will do is, let's try. So what we'll do is over here. Let me use maybe pink. That means we are creating d2 over here, and then we are trying to get a directory object over here. Directory, and we got files, number of files, and also we got the name. Okay? And now I want you to look at when we try to call this particular line, as I said before, it's basically calling the helper constructor, which is over here. And you can see that from that helper constructor, we are basically creating a new string for the name, right? So now, how can we initialize the value for the name over here? Is it still going to point to the same d over here? No, it's going to be a new object. Okay, that's number one to notice. Okay, let me draw that quickly. That means it's going to have something like this. So that means n is also going to point to a new string called d. So the d over here is different from the d over here. Completely different string objects because of the new string we have over here. Okay? Good. That's what you would do. And also, it's going to actually try to initialize the files into a new array. Okay? So what I would do is, and also number of files will be 0. Let me try to draw like this. Okay? It's going to be something like this. 0, 0, 1, 2, all the way to 99. Okay, that's what you will do. And so far, all the pink array over here is pointing to null, right? Every slot to begin with. Now, what we want to see is exactly how this for loop over here is going to be executed, this part over here. That's a part. Let's do that quickly, just for one iteration, just for one. How do we do that over here? Well, in the very first iteration, I is going to be 0. So that means we have some file called source. And it's going to be other, in this case, which is D1. D1.files at position 0. D1.files at position 0 is referring to this particular object, right? And now we are saying source is simply just pointing to that. Okay, just that. Okay, so far so good. Just source. It's just an intermediate variable. Okay, it's only aliasing intermediate at the intermediate stage. And then we have the next line over here. And then we try to have a new file over here. And then make it a new file over here. You can see over here we're calling the copy constructor from the file class. And then we pass source. Okay? And what does the copy constructor for the file class do? Well, it's defined exactly over here. We're going to create a file object and make sure the name is going to be a new string. Okay? What does that mean? Let me draw that very quickly. That means what this will do. Okay, let me just say this is the critical line. What this line will do is it's going to create just a new file object over here. Okay, it's going to be a file object here. And then the file has a name. And then the name is just going to make a copy of f1.txt, right? And then it's simply just going to point to f1.txt. Okay? And then we're going to call that new file nf. One thing to note as you review the lecture, you can see the source over here, and the nf over here, they're different objects. Okay, I'll write it down explicitly. That's really important. So nf is not the same as source. Okay, final step for the iteration. And then we call this dot add file. This add file, and then we pass the new file over here. So that means currently the number 5 will be 0, and then we simply say this should point to this particular file over here. Okay, now, is there any aliasing between the files of the two directories? Specifically, let's try. When I say d2.files equals d1.files, would that be true or false? Well, d2.files is referring to this array here, right? d1.files is referring to this array, different array. So that should be false. What about if I say d2.files at position 0 equals d1.files at position 0? True or false? False, right? Because d2.files is this array over here, and I talk about position 0, which is this file object over here. Whereas I'm talking about 0 position for d1.files, which is this file object, so they're different. Okay, so that's also false. There's no sharing. Okay, so now one more thing to point out, and then I'll let you go. Okay, one more thing. So now, this is why the composition can be satisfied by this deep copy. If you look at this final assertion over here, after I try to change d2.files into f11.txt, so f2 over here, d2 over here. So d2, and then I try to change the file name into, over here, into f11.txt. It is not going to change the files under d1. Okay, it's different objects. So that's why you will see it is true. Okay, so it remains to be f1.txt. Okay, I would say that's quite a sophisticated example. I would say go over that by yourself on the paper. Okay, that will save you on the lab test too. Okay. I'll see you on Wednesday.